Morning all of you. Welcome back to course database management system. So our today's topic of video is join operation. So in the previous video we discussed about query processing. We understand how query is being processed by your database. So today we are going to discuss about join operation. So before this we already discussed about join operation. We come to know that what is join. So what is join and when do we require join operation? When we need to fetch a data from more than two table, at that time mostly we are using join operation. So join operation can be performed on more than two or more table. Join operation can be performed. So join operation is a combination of two operations. What are the two operations involved in a join operation? One is a Cartesian product operation and second one is a selection operation. These are the two operations of a join operation. Okay, so we know that what are the different types of join. We heard about natural join, left outer join, right outer join, full outer join, equi join, non-equi join. These are the various types of join operations are there. But in this case we are going to discuss about join operations involved. So why there is a need to learn this join operation? Why do we require? So for that purpose I am telling you why there is a need of join operation. See, your database is being stored on a hard disk. But do you know how your data is being stored? Your data is stored in the form of block. Means in case of on the hard disk, your database is stored in the form of blocks. There are n number of blocks are there. In that block, you are going to store your data. So for that means in this, based on this particular topic, mostly you will find the question of estimating the number of block access required by using various join strategy. For that purpose you need to know what are the different join operations are there. Means actually we need to calculate the number of block access required if we are using different types of join, because different join operation have different strategies are there. So in that case we need to estimate how many blocks we need to use, or how many blocks we need to access for performing particular join operation. So what are the different join operation? So first one is a nested loop join, block nested loop join, index nested loop join, merge join and hash join. These are the various types of join operation. I am not telling you that these are the types of join, but actually these are the join operations. Okay, so one by one we'll discuss all these operations. And you need to understand the formulas, because based on this you find numerical in GATE exam also as well as in your university exam also. So in case of a nested loop join, this is what a simple algorithm is there. So we need to understand this algorithm as well as we need to understand the formula. This formula is useful, that we need to estimate the number of block access required in the worst case as well as in the best case. So before discussing the formula, first of all we need to discuss the algorithm that is used for nested loop join, how it works. In this case, for each tuple tr in R do begin. So in this case R is one relation and S is another relation, and we need to perform join operation on that. So in that case how join operation will takes place. So and in join operation we already know that Cartesian product will be there, and how Cartesian product works, every row of one table is combined with every other row of another table. So based on that concept this algorithm works. For each tuple tr in relation R, this is given in the outer for loop. Then we have inner for loop. In the inner for loop we are considering for each tuple ts in S do begin, and then we are checking condition. We know that in case of a join operation one important condition is there. What is that? We required one common attribute between the two relations. Suppose I need to perform join operation based on two relations. So what is important? That two relations should have one common attribute, and based on this common attribute you are going to perform join operation. So here you are going to test tr comma ts to see if they satisfy join condition. If first row of first table compare with first row of second table, if both the row should have common attribute, then we can add this result. So then we can add this row to our result. We can add this row to our result. If the condition is not satisfied, then first row of first table compared with second row of second table. Suppose it does not satisfy the condition. If suppose it does not satisfy condition, then you are not going to add this in the result. So in this way this particular nested loop join works, and you need to test this condition, then inner for loop will end and then outer for loop will end. Means every row of one table is compared with every other row of another table. So this is what a algorithm for nested loop join. And in the worst case, suppose you need to calculate how many number of block access required. Suppose you are using a nested loop join strategy. So for that purpose you need to use this formula in the worst case. So what is the formula? Total block access equals to NR into BS plus BR. So in this case, what is NR? NR is nothing but number of tuples in relation R. BS means number of blocks for relation S, and BR is number of block for relation R. So I already explained what is the use of block. Actually your data stored in hard disks in the form of block. Okay, and in this case you need to what you need to do, and each block having different capacity. Okay, for suppose you need to calculate how many blocks are there. What you need to do, you need to divide total number of row divided by the capacity of one block. Suppose the capacity of one block is of 25 records, 30 record, 40 records. So you need to divide the total number of records with capacity of one block. So that you will get a number of blocks for that particular relation. Then you need to use this formula to calculate the total number of block access required. Suppose you are using the concept of nested loop join, and in case of best case, your formula is very simple: BR plus BS. BR means number of blocks in relation R, and BS means number of blocks in relation S. So this is a formula that you need to remember for nested loop join. Similarly, next is a block nested loop join. Okay, so in the previous case we have just seen nested loop join. So in this case we are also going to consider blocks. Okay, in the nested loop join we have just considered the number of rows in relation R and S, but in case of block nested loop join, as its name suggests, here we are considering every block. Okay, so here for each block BR of relation R do begin, for each block BS of S do begin. So this is what a outer relation, this is what a inner relation. So for every block of outer relation is combined with every block of inner relation. Okay, then same thing for each tuple TR in BR do, for each tuple TS in BS do. Means in this case we are considering the row in complete relation, but in this case we are considering the row present in a particular block. Okay, that's why its name is block nested loop join. Again condition is same. You are going to test this condition TR comma TS. If they both have common attribute, if they satisfy join condition, then they will be added to your result, otherwise it will not be. So here you can see 4 end, because 4 for loops we are going to use over here. So 4 end is there. So how to calculate the total number of block access? Suppose you are using block nested loop join. So formula is BR into BS plus BR. In this case formula is different. So BR and BS means what? Number of blocks in R and number of blocks in S. And the best case formula for nested loop join as well as for block nested loop join is same. That is BR plus BS. Now next one is index nested loop join. So in case of index nested loop join, what you are going to use? You are going to use the concept of index. And for index nested loop join, there are no formulas given for best case as well as for the worst case. So next we are going to discuss about merge join. So what are the formula that you are going to use to calculate the total number of block access in case of a merge join? So in case of merge join, best case formula is same, that is BR plus BS. So in this case either you consider relation R or S, otherwise you can say relation R1 and R2. So in case of, see, you need to remember one thing: the best case formula for all types of join operation is same. Okay, So in case of merge join also, the formula is same. Now in the worst case, what will be the formula? So one change will be there in the merge join. Separate formula is used for relation R2 and separate formula used for R1, and then you are going to add this in case of worst case. So how to calculate total block access required for relation R2? BR2 into 2 log base 2 BR2 divided by 3 plus 1. So this is what a formula that you need to use. So this is for relation R2, this is for relation R1. So in this case you need to remember, you need to consider log base 2. This is important. So here 9 is not there, actually it is opening bracket will be there. So you need to use this formula to calculate total block access required in R2, then total block access required by R1, then whatever the value that you are getting you need to add, so that you will get total number of block access in a worst case. So in this way you can calculate total block access required for merge join. And the last type of join operation is a hash join. So in case of hash join, there will not be any worst case, but only best case is there, and its formula is almost same, but only it will be multiplied by 3. Here you can see best case formula is BR1 plus BR2, but in case of hash join you need to multiply BR plus BS into 3, or you can say 3 into BR1 plus BR2. So it's only notation. Either you can say relation R1 or R2, you can say relation RS, you can say relation X, relation Y. In this way you need to consider all these things. So all these are the types of join operation, and based on this you will get a numerical in the GATE exam as well as in your university exam. So what type of numerical you will get? You need to calculate the total number of block access required by using different types of join operation. So we discuss about 5 different types of join operation, out of which index nested loop join didn't provide any kind of worst case or best case formula. Okay, so I hope you understand join operations involved in join operation involved in database. And in next video we are going to discuss the numerical. We'll see how to solve numerical based on this join operation. Thank you.